Hello again, Mrs. Hoekstra here. Module 2, Lesson 16. I'm on page 94. Applying the properties of operations to multiply and divide rational numbers. All right, essential question. What properties do you need to use to make multiplying and dividing rational numbers easier? Okay, I don't want you guys to have to struggle through doing these problems on your own, paper, pencil, in your own head, whatever. Using properties will make it a lot easier for you. All right, so example 1, using the commutative and associative properties to efficiently multiply rational numbers. Remember, the commutative property says I can flip-flop the numbers around, right? I can change them. Associative property says I can group them in a certain order. All right, so let's take a look at this first one. I'm going to do this one just kind of straight across, not using any shortcuts. All right, so I'm just going to rewrite it though. -6. I like to use parentheses for my multiplication. I don't like to use the x because x is a variable. We're heading into algebra class. I want to get away from using x's for multiplication. So I'm just going to use parentheses to show my multiplication. All right, so according to this, I just work my way left to right. So -6 times +2 is -12. And then I'm going to leave everything else as is, right? -2, -5, and -3. All right, then order of operation says multiply the next two. So a negative times a negative is a positive. 2 times 12 is +24. And then I still have the -5 and -3, right? I'm taking the long way there, I know. Next, I'm going to multiply 24 times -5. Not something I know off the top of my head, but a positive times a negative is a negative. And when I multiply this, I believe I get 120. And then it is still times -3. A negative times a negative is a positive. 120 and 3 gives me 360. Now, like I said, I can multiply straight across. The problem becomes when I get to a number like this, when I get to this point, it isn't something I necessarily know off the top of my head. I may have to go off to the side and do, the multiplication written out versus doing it in my head. Okay, so let me show you guys a different way of looking at this. Okay, I'm going to once again start by writing out the original problem. -6 times +2 times -2 times -5 times -3. Okay, exact same problem, haven't done anything. All right, now we could have done it slightly differently in the first problem, where I could have multiplied the first two just like I did and still get -12. But then what I could have done was maybe just multiplied the next two as well, because I know negative times a negative is a positive. And I also know that 2 times 5 is 10, and that makes multiplying way easier when I've got a 10. All right, and then I'll just leave my -3 as is. Okay, so I'm just going to set it up that way. And yes, I could have done it in multiple steps as well, but I want to put those next two together because it does make my life easier. So now the question becomes, do I want to go straight across? Do I want to mix things up? It really probably doesn't matter at this point. So I'm actually going to multiply at this point straight across because I find multiplying by 10 easier than multiplying by the 5. Even though multiplying by 5 is easy because it was with a 24, it made it more difficult. But negative times a positive is a negative, and 12 times 10 is 120. That makes it pretty easy. My -3, haven't done anything with it. Right, just keeps coming along. All right, well, I know 3 times 12. 3 times 12 is 36. So I know that this is going to be 360. I have two positives, so my answer is positive 360. All right, so sometimes multiplying certain numbers together make it easier for you. All right, so what types of strategies were used to evaluate the expressions? Well, the first one I used order of operations. Right? I used the order of operations. I went left to right. I went left to right and just worked my way across. Versus the other one, I used the commutative property, I used the associative property because I grouped them. I used the associative property to group numbers to make easier. Right? I do find multiplying 12 times 10 a lot easier than 24 times 5. Okay, so what was the benefit? Definitely certain combinations of numbers make multiplying easier, right? So look for combinations to make multiplying easier. As long as you're not breaking any of the math rules, this should make life less complicated. Okay, what was the sign of the product and how was the sign determined? Okay, so the sign at the end was positive, right? Now remember, I showed you in class a few days ago a shortcut, and all we had to do is count 1 negative, 2 negatives, 3 negatives, 4 negatives. There's 4 negatives. There are 4 negatives, right, in the original. And 4 negatives, 4 is an even number. And that makes it positive. Remember I said it was like an on-off switch, and we just switch it back and forth and back and forth and back and forth. All right, so let's go across the page here. I'm on page 95. Find an efficient strategy to evaluate the expression. Okay, I want you guys to hit pause here a second just for this one. Okay, we're going to pause. When you're done with exercise 1, go ahead and turn it back on and we'll see how you did. Just this one. Go ahead and hit pause. Okay, so what I did was I put the first two together, -1 times -3, and got a +3. I left the 10 as is, and then I multiplied the second, or the back two there, the -2 times +2, and got a -4. And so then what I did was I also switched the order. I did the commutative property and just put the 3 and the 4 together because I know that that makes 12, right? So I have a -12 because the 3 was positive, the 4 was negative, and I left the 10. And then I multiplied by 10 at the very end because I find that to be very easy. Could you have just gone straight across? Sure. Could you have gone straight across at my second step? 3 times 10 is 40. 40 times, 3 times 10 is 30 times -4 and gotten the -120 as well? Sure. However your brain sees it, put it together, okay? I just find doing it in this particular order was easiest for my brain. All right, we're going to do the exercise 2 together though. All right, I want to do this one together. All right, find an efficient strategy to evaluate the expression and complete the necessary work. So just look what we have. 4 times 1/3 times a -8 times a 9 times a -1/2. Now, if I go straight across, this number is going to get kind of messy because I can't nicely take 1/3 of the number 4. All right, but if I rearrange it, there might be a combination that makes it easier. Same thing with taking half of a 9. Doesn't work nicely. So I want to try to maybe take 1/3 of a number that's a multiple of 3 and maybe take a half of a number that's some kind of an even. All right, so I'm going to rearrange these. I'm going to leave the 4. All right, what I'm going to do is I'm going to just change the order of those two for a moment. Okay, so I'm going to write this as -8, and then I'll put the 1/3, then the 9, and then the -1/2. Okay, pretty easy. The reason I want to do that is because 1/3 times 9 is the same thing as taking 9 and dividing by 3. I'm actually going to leave the 4. I'm not going to multiply by any of that, but I am going to change this one. 9 divided by 3 is really what we're doing, or 1/3 of 9, excuse me, is 3. And then I'm going to take my 1/2 still, -1/2. Okay. I think what I'm going to do is, again, flip-flop the order. I'm going to change these two around. Okay. I'm going to leave my 4 out front. 4 times -8 times -1/2 times 3. Okay, just flip-flop the order. And the reason I want to do that is because it's pretty easy to take a half of an 8. Okay, so I'm going to leave my 4. And half of 8 is 4. A negative times a negative is a positive. and then I've got my 3. Okay, now I could do 4 times 4, which is 16, and 16 times 3, I don't know that off the top of my head. But if I do 4 times 3, I know that that's 12. And I'll just leave the 4 out front again. And I'm going to make this 12 because I know 4 times 12 is 48. That is one that I know. I don't know my multiples of 16. I know my multiples of 4 and my multiples of 12, though. So I find that way to be easier. Could you have done 16 times 3? Sure. Some of you are good at that. Fine. Okay. So what terms did we combine first? What terms did we combine first? Well, I personally wanted to put my fractions together, right? Get things that were going to work nicely. Combine the fractions with numbers that work well with the denominators. Okay, so if you know, oh yeah, that's a multiple of 3, that's a multiple of 6, that's a multiple of 2, whatever the numbers are, pay attention to that so that they work nicely with those other numbers. It's going to make your life a lot easier. Going straight across, yes, you'll get the same answer. It's just going to be much more work for you. And I don't want you guys to have more work. All right, let's take a look at exercise 4. Okay, refer to the example and exercises, so what we just did. Do you see an easy way to determine the sign of a product first? Well, we talked about this the other day. So let's see here. If there's an even number of negatives, right? An even, underline, number of negatives. An even number of negatives equals a positive answer. Okay, and an odd number of negatives, and we're talking about in that original beginning problem, equals a negative answer. Okay, example 2 says using the distributive property to multiply rational numbers. Now the distributive property says everything is inside these parentheses are going to get multiplied by something on the outside. Okay, so to make life easier, like look at 6 times 5 1/3, not something that is easily done without a calculator. And of course, we don't have a calculator. So let's work this out. We have -6 times 5 1/3. That's my original problem. Now remember, we talked about splitting these rational numbers up. -6, and this becomes 5 plus 1/3, right? I can do that. That's totally legal. Now the distributive property says everything inside that parenthesis is going to get multiplied by -6. So I'm going to multiply there and all the way over to there. Everything inside gets multiplied by -6. So in other words, -6 times 5 plus, because there's the plus sign, the -6 times the 1/3. I'm not going to freak out that there's a fraction because I noticed the denominator in my fraction and my whole number work nicely together. They're both multiples of 3, so it makes my life easy. All right, well, I know 6 times 5 is 30. I have one negative in here, right? I've only got one negative, so that's negative. Plus, and I'm going to take 1/3 of -6, okay? 2, 4, 6, right? -2, -4, -6. I'm going to take 1/3 of it, so this is -2. Or you could think of it as -6 divided by 3, and you would still get -2. Okay? Well, notice both of my numbers are negative, so I literally can just add them, and I get -32. See? You looked at it originally and went, oh, I can't do it without my calculator. Sure you can. Just break it up. Break it into easy pieces. Okay. Multiply the expression using the distributive property. I would like you to try this one. I will warn you, it isn't nice like my last one, all right? But I do want you to hit pause. I want you to give it a shot, Go ahead, hit pause right now. Check back with me in about a minute. All right, so 9 times negative 3 1/2. Break your negative 3 1/2 into negative 3 plus a negative half. If you make a mistake, it's going to be forgetting that that has that negative as well. The whole fraction was negative, remember. All right, now 9 times negative 3 is negative 27, and 9 times negative half is negative 4 1/2, right? You have $9. Your parents say you got to share it between you and your sibling, and so you each get $4 1/2, negative 4 1/2 in this case. So then you can put them together because they're both negative. Pretty easy. All right, take a look at the top of page 97. So we are going to use the distributive property, but differently this time. Okay, we're going to undo the distribution. Okay, we're going to undo the distribution. It's like, you know, your teacher handed out a paper and all of a sudden they're like, oh, hang on, that's the wrong paper for the wrong class. Give them all back to me, right? They undo it. They undistribute. They take them all back. Well, take a look at what's going on in this problem. Okay, we have 16 times negative 3/8 plus 16 times 1/4. What do you notice both of those have? They both have a 16. So I'm going to take the 16 away. I'm going to undo it. I'm going to take the 16 out. And what do I have left? I have a negative 3/8 that's going to get added to a positive 1/4. Okay, it looks just like the opposite of what we did in the last two problems. Okay, well, my fractions don't have common denominators, right? 1/4. If I multiply both the top and the bottom by 2, I get 2/8. So I'm just going to rewrite this as 16 and then times what? Negative 3/8 plus a positive 2/8. And negative 3/8 is bigger. So that becomes what? Negative 1/8. So 16 times negative 1/8. I just said that. Negative 1/8. Well, multiplying by 1/8 is the same as dividing by 8. So I could take 16 divided by negative 8. It's the same thing. 16 divided by negative 8 is negative 2. All right. Well, let's try this one here. So I have 1 divided by 2/3 times negative 8 times 3 divided by negative 1/2. All right, so I think what I'm going to do, I'm going to start by dealing with those division problems, because when I divide a fraction, I actually multiply by the reciprocal. Okay, remember that from the last book. So I've got 1, and now I'm going to multiply by 3/2, because it's the reciprocal, right? And then multiply by negative 8, then times negative 3, and then again multiply by the reciprocal. Get all the way over here. And I have negative 2, or negative 2/1. Okay, well, my problem with this is that it may not necessarily always work nicely with everything that's going in order, but I think I'll be okay. I'm going to put my negative 8/1. All right, and then if you remember, I talked to you guys about cross-reducing, because I know 2 goes into itself once and 2 goes into negative 8 -4 times. All right, and now really what I have is just one big string of multiplication. I have 1 times 3, because it's 3/1, but that's just 3, times negative 4/1, which is just negative 4, times negative 3, times negative 2, right? I have 1, 2, 3 negatives, so I know my answer is going to be negative. Is that right? Do I have 3 negatives? Oh, that's not a negative 3, that's a positive 3. Pay attention, Mrs. Hoekstra. Wow. So this is a positive 2, or excuse me, a positive 3. So I only have 2 of them, so my answer is going to be positive. All right. Well, I can do 1 times 3, which is no big deal. So 3 times negative 4 is negative 12, times 3 times negative 2, which is negative 6. 12 times negative 6. Negative 12 times negative 6 is positive 72. Well, I would like you guys to try exercise 6 on your own. I want you to hit pause. As soon as you have that one done, check it. It will work out nicely, I promise, but you may want to rearrange a few things and pay attention to the fact that we have a division problem. All right, hit pause. Okay, so I took 4.2 times negative 1/3 times 6, because remember we're dividing by 1/6, so we use the reciprocal, and then times negative 10. So I dealt with the two fractions first because I knew that the denominator with the 3 works nicely, cancels out, and makes that 6 become a 2 because 3 goes into 6 twice. I can cross reduce that. And so I end up with 4.2 times negative 2 times negative 10. I put the 4.2 and the 2 together because multiplying by 2 is very easy. So that becomes negative 8.4. Multiplying by 10 just moves your decimal point over one time. Negative times a negative is a positive. Positive 84. All right, there you go. I hope you guys understood and got through this okay. And I will see you all later.